Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 12 on the chapter of parallelograms, where I will solve the test paper 17, which are multiple choice questions. Even though I will not solve all the problems because some problems are repeated from previous exercises on this chapter, I will do only there are also some theoretical problems. I will skip those. If you have not watched the previous all the parts videos, part 1 to part 11 on this chapter of parallelograms, then I strongly suggest and request that you please watch those videos also to maintain the continuity of your study on the chapter of parallelograms. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with the solving of test paper 17 on the chapter of parallelograms. Okay, I have the questions of test paper 17 on the left hand side. I hope the fonts are big enough so that you can read them properly. On the right hand side, I will solve the problems. Now, the first six problems, some problems are theoretical and some problems are repeated. I won't solve the repeating problems and as well as any theoretical question. I will possibly discuss them in a very brief manner. So, the question 1 is theoretical. Define the terms. Question 1, it is asking to define the terms open curve. Now, what is open curve? Open curve is this is a concept of the polygons. Open curve means a curve that do not end at the starting point. So when we draw a curve, there is a starting point. We start from some point, and then when we finish drawing the curve, we end at some point. If these 2 points, if the ending point, for example, I am drawing a let's say I am drawing this curve. So this was the starting point and B is the ending point, and since A and B are not the same point, this is an open curve. Similarly, let's say I start this curve is also not this is an open curve because I started from the point A and I ended at the point B. So this is these two curves are open curve. Okay, now what is closed curve? Closed curve is a curve that ends at the starting point. So a curve, closed curve is a curve that ends at the starting point. That is, when we draw a curve, if the starting point and the end point are same, then it will be a closed curve. For example, this is a closed curve. So I started at the point A and the point B also coincides. So the ending point, I ended at the point where I started in drawing this figure. Similarly, this will be a closed curve. So this is the point I started and this is the point where I ended in drawing the curve. Also, this is a closed curve. I started at the point A and also ended at the same point. So these are closed curves. Okay. The third one is, what is a simple closed curve? What is a simple closed curve? A simple closed curve is a closed curve, a closed curve, a closed curve that do not intersect with itself, that do not intersect, that do not intersect with itself. For example, this curve is not a simple closed curve. Even though this is a closed curve, I started at this point and I ended at the same point, but there is a point of intersection. C is the point of intersection. This is the point of intersection. At this point, the curve intersects with itself. Point of intersection. So this is not a closed curve. This is not a simple closed curve. A simple closed curve is, let's say, this is a simple closed curve. This is a circle. Or this is a simple closed curve. This is a triangle. These two figures are not intersecting with itself. Also, all polygons are a simple closed curves. Okay. Let's see question number 2. The angles of a quadrilateral are in the ratio 1:2:3:4. Find the measure of each angle. Okay. So it is talking about a quadrilateral, the angles of a quadrilateral. Okay. So let the angles be x degree, 2x degree based on the given ratio, 3x degree and 4x degree. This will imply, we know the sum of the interior angles or sum of the angles of a quadrilateral is equal to 360 degree. So we must have x degree plus 2x degree plus 3x degree plus 4x degree. This is equal to 360 degree. Simplifying the left hand side, we get x plus 2x plus 3x plus 4x is 10x. So we have 10x degree is equal to 180 degree. We can, ignoring the degree, we can say that 10x is equal to 180. This implies x is equal to 180 by 10, that is 18. So this implies angles are first will be x degree, that is 18 degree, and the second will be 2x degree, that is 2 into 18 degree, which is 36 degree. The third angle will be 3x degree, that is 3 into 18 degree, which is 54 degree. And the last one will be 4x degree, that is 4 into 18 degree, which is 72 degree. I hope I did the calculation right. If we add up 18, 36, 54 and 72, is will it be, it should be 360. So we have okay, 54 and 54 is 108. No, we are, oh sorry, so this will be not 180 but 360. I am prone to make silly mistakes. So if my answers are incorrect, if I come up with wrong results, then it will be most probably it will be due to calculation mistake. So if I am doing any kind of calculation mistake, please do let me know in the comment section. I will appreciate that. So this is 36 degree. This will be all 36 degree. Okay, so 36 degree. So the angles are 36 degree. X is 36 degree. 2x is 2 into 36 degree, which is 72 degree. 3x is 3 into 36 degree, which is 108 degree, and 4 into 36 degree, which is 144 degree. I hope this is right. Okay, so that was question number 2. Let's do question number 3. The two adjacent angles of a parallelogram are in the ratio 2:3. Find the measure of each of its angles. Two adjacent angles of a parallelogram. So if we have a parallelogram, let's say this is a parallelogram ABCD. So these two are one pair of adjacent angles. So let's say we assume that it is given angle A is to angle B are in the ratio given 2:3. So let angle A is equal to 2x degree and angle B, based on the ratio, angle B is equal to 3x degree. Now this will imply, since angle A and angle B are a pair of adjacent angles in a parallelogram, the sum of a pair of adjacent angles is always 180 degree. So we must have angle A plus angle B should be equal to 180 degree. So this implies 2x degree plus 3x degree is equal to 180 degree. So this implies 5x degree is equal to 180 degree. This implies 5x is equal to 180. This implies x is equal to 180 by 5. This is 36. So this implies angle A will be equal to 2x, that is 2 into 36 degree, which is 72 degree, and angle B, now angle A will be equal to the opposite angle in the parallelogram, so it will be equal to angle C. So angle A and angle C both are equal to 72 degree. Similarly, angle B will be equal to 3 into 36 degree, which is 108 degree. This will also be equal to angle D, because angle B and angle D are pair of opposite angles in the parallelogram and they are equal. Okay. Let's do question number. So this was, all these are section A. Section A. Section A. Question number 4. Question number 4 says the sides of a rectangle are in the ratio 4:5 and its perimeter is 180 centimeter. Find its sides. I will not do this problem because I have already solved this kind of problem in the previous video, that is while solving the MCQ problems. That is, it should be either solving 16A, exercise 16A or 16B. Question number 5 is skipped. So question 4 is skipped. Repeated question. This is repeated question. Question number 5. Prove that the diagonals of a rhombus bisect each other at right angles. Okay, so this will be a little tedious work. Let's see. We have to prove that the diagonals of a rhombus are bisect each other at right angles. So we know that a rhombus is a parallelogram where all the sides are equal. So let's quickly draw a rhombus. So these two are equal. So it's a parallelogram. It's a parallelogram where all the sides are equal. So let's say ABCD. ABCD is the rhombus. So AC is the one diagonal. AC is one diagonal and BD is another diagonal. We have to prove that, let's say, the diagonals intersect at the point O. We have to prove that the diagonals bisect each other at right angles. That means to prove what we have to prove. To prove that OD is equal to OB, AO is equal to OC, and of course angle AOB is equal to angle AOD is equal to 90 degree, as well as angle BOC is equal to angle COD equal to 90 degree. All these things we have to prove. Okay. So what do we know? We know that all the sides are equal since it's a rhombus, and we have the opposite pair of sides are parallel. So AD is parallel to BC and AB is parallel to CD. Okay. Let me draw the diagonal AC properly. Okay. Let's consider the triangle AOD and triangle. We will try to prove that these two triangles AOD and BOC are congruent. If we can prove somehow these two triangles are congruent, I think that what has been asked to prove, it will be proved. Okay, so what do we have in the triangles AOD and BOC? This angle is equal to this angle, alternate interior angles, since AD is parallel to BC. So we have angle OAD is equal to angle OCB. Why? Because AD is parallel to BC and AC is a transversal. Okay, what else do we have? We will have another pair of alternate angles equal. We will have this angle will be equal to this angle. We will have angle ADO will be equal to angle CBO because AD is yes, for the same reason AD is parallel to BC, but this time the transversal will be different. The transversal is BD. BD is the transversal. We have this, and finally we have the side AD should be equal to BC. So we have one side AD is equal to BC, and we have the two angles at the opposite ends of the two equal sides. So definitely this is we are having angle side angle satisfied, congruency satisfied. Okay, now we have to name the we have to establish the congruence relation properly. So definitely, let's try to establish the correspondence between the vertices. Now, we have angle OAD. Angle OAD is equal to angle OCB. This thing actually means that angle A of triangle OAD is equal to angle C. Actually, this now angle A will be this will be confusing, because angle A means the angle A of the rhombus, and angle C also means the angle, it's a angle of the rhombus. Okay, now now angle OAD equals to angle OCB. This means this will imply that A will have definitely a correspondence with C, because if you consider the angle, the triangle OAD, angle OAD, in triangle OAD, the angle OAD is at the vertex A, and in triangle OCB, the angle OCB is at the vertex C. So A must have a correspondence with C. Okay. Similarly, we will have D will have a correspondence with B, because since angle ADO is at the vertex D and angle CBO is at the vertex B. So D will have a correspondence with B. So this will imply the third correspondence of the third vertex will automatically imply. So we must have O should have a correspondence with O, as O is the common vertex. So the congruence relation between the triangles AOD and BOC will be triangle AOD will be congruent to A corresponds to C. So C, O is O, and B, COB. Now from this congruence relation, we can say that AO will be equal to CO. AO is equal to CO. Also, OD will be equals to OB. We have OD equals to OB. So these two proves that the diagonals are bisecting each other at the point O. That is the point of intersection of the two diagonals. Now we have to prove that they are bisecting at right angles. Now from this congruence relation, we will also have angle AOD. Angle AOD should be equal to angle COB. Angle AOD is equal to angle COB. That is anyway true, because these two are vertically opposite angles. How can we prove that they are intersecting at right angles? This angle we have to actually prove that in triangle AOD, angle OAD plus angle ADO is equal to 90 degree. How do we prove that? This angle equals to this angle. This angle. rhombus. Okay. This one. Now we can, if we consider the triangle ADO and AOB, the triangle ADO and triangle AOB will also be congruent, because AD is equal to AB, AD is equal to AB, and we have the common side AO. No. Okay. No. Now in triangle ADB, angle ADO is equal to angle ABO. We have to prove angle AOB is equal to angle AOD. Angle AOD is equal to angle AOB. Angle AOB. This angle equals to this angle. We have common side. This side. No. Okay. Now, yes, we can prove that triangle ADO will be congruent to triangle AOB, because let's say if this is x degree, then in triangle ABC, AB is equal to BC, so this will also be x degree. This will also be x degree, and okay. Now, if this is now, so angle OAB is equal to angle OAB is equal to angle OCD, as they are alternate interior angles. So this will also be x degree. This will be x degree, and then in triangle ADC, AD is equal to DC. So this angle will also be x degree. So we can see in triangle ADO and triangle AOB, in triangle ADO and triangle AOB, AO is the common side, AD is equal to AB, and also the included angle are equal. So we are having so now I am just trying to prove that the diagonals will intersect at right angles. So that is why I am trying to prove that triangle AOD is congruent to triangle AOB, because and from the congruence relation we will have that angle AOB is equal to angle AOD. Now angle AOD and angle AOB are linear pair of angles. The addition will be equal to 180 degree. let me so in triangle, so far we have proved that the diagonals are bisecting are bisecting each other, as we have proved AO is equal to CO and OD is equal to OB. Let me now prove the diagonals are intersect. The diagonals will intersect at right angles. Let me duplicate this copy and solve. Okay, now consider in triangle AOD and triangle AOB. We will try to prove these two triangles are congruent. We already have the angle DAO is equal to angle OAB. That is, they are both equal to x degree. Also, we have AO is equal to AO, the common side. And we have also AD is equal to AB, as they are the sides of the rhombus. So this will imply that one angle at two sides and the included angle are equal in the two triangles. So definitely this is angle ASA, angle side angle congruency satisfied. So a triangle AOD and AOB must be congruent to each other. Let's try to establish the congruence relation properly. Triangle AOD will be congruent to AO is equal to AD is equal to AB. So definitely A will have a correspondence with A only and D will have a correspondence with B. So this will definitely be O. So triangle AOD is congruent to triangle AOB. So this will imply that angle AOD should be equal to angle AOB. Also angle AOD plus angle AOB is equal to 180 degree, as these two angles are linear pair. So this will imply we can say angle AOD, angle AOB is equal to angle AOD. So angle AOD plus angle AOD is equal to 180 degree. So this will imply twice of angle AOD is equal to 180 degree. This will imply angle AOD is equal to 90 degree. So we clearly have AOD is 90 degree. So definitely then angle AOB will also be 90 degree. Hence the two diagonals are perpendicular are intersecting at right angles. So this proves that AC and BD intersects at 90 degree or one right angle. Hence it is proved. Okay. I will not do the question number 16 because it was already done in previous video. Skipped. Already solved in some previous video. Okay. So that was section A. Now section B. These are multiple choice questions. Section B. Question 7 says two opposite angles of a parallelogram two opposite angles of a parallelogram are 3x minus 2 degree and 50 minus x degree. So the measure of all the angles are. So is given that, let's say this is the parallelogram ABCD. So these two, let's say these two are opposite pair of angles. It is given that two opposite angles of a parallelogram are 3x minus 2 degree. So let A be equal to 3x minus 2 degree, and its opposite angle is C. C is equal to 50 minus x degree. Now we know that the opposite pair of angles in a parallelogram are equal. So we must have angle A is equal to angle C. So this will imply 3x minus 2 degree should be equal to 50 minus x degree. So this will imply, if we ignore the degree, we have 3x minus 2 is equal to 50 minus x. This implies that this is a linear equation in x. If we solve for x, we have 4x is equal to 52. So this implies x is equal to 52 by 4, which is 13. X is 13. So this implies angle A is equal to 3 into 13 minus 2 degree. This is 39 minus 2 degree. This is 37 degree. So angle A will be, angle A and angle C are equal. So this will be equal to 37 degree. Angle A and angle C are 37 degree. Now what will be angle B? Angle A and angle B, since they are adjacent angles, pair of adjacent angles in the parallelogram, their sum should be equal to 180 degree. So this implies an angle A is 37 degree. So 37 degree plus angle B is equal to 180 degree. So this implies angle B is equal to 180 degree minus 37 degree. This is equal to 143 degree. So angle B is equal to angle D is equal to 143 degree. So definitely the correct choice is angle A is 37. So it will be angle B is 143. So 37, 143, 37, 143. So the correct choice is D is the correct choice. Sorry, B is the correct choice. B is the correct choice. Okay, let's do question number 8. The angles of a quadrilateral are in the ratio 1:3:7:9. The measure of the largest angle is. Okay, now I will, so let the angles be, let the largest angle will be based on the largest part in the given ratio, that is 9. So let the angles be, the ratio of all the angles of the 4 angles in the quadrilateral is given as 1:3:7:9. So let the angles be x degree, 3x degree, 7x degree and 9x degree. We know that the sum of all the angles sum of the angles in a quadrilateral is 360 degree. So we must have x degree plus 3x degree plus 7x degree plus 9x degree should be equal to 360 degree. Simplifying the left hand side, we get x plus 3x is 4x, 4x plus 7x is 11x. We have 20x degree is equal to 180 degree. So this implies 20x is equal to 180. This implies x is equal to 180 by 20, which is 9. So therefore, largest angle will be equal to 9x, that is 9 into 9 degree. This is equal to 81 degree. So the largest angle is 81 degree, and hence the correct choice is C. C is the correct choice. C is the correct choice. Let's do question number 9. The length of a rectangle is 8 centimeter and each of its diagonals, measures 10 centimeter. The breadth is, this is also a type of question that I have already solved in some previous video while solving exercise 16a or 16b. So I am not doing this problem. Skipped. Already done. Question number 10. In a square PQRS, PQ is equal to 2x plus 3 centimeter and QR is equal to 3x minus 5 centimeter. Then x is, we have to find the value of x. Okay. So we are given a square. The square is given as PQRS. And it is given that PQ is equal to 2x plus 3. Okay, so PQ is 2x plus 3 centimeter, and QR is given to be 3x minus 5 centimeter. This is a pretty straightforward question. We know in a square all the sides are equal. So this will imply that PQ is equal to QR. So this will imply 2x plus 3 centimeter should be equal to 3x minus 5 centimeter. So this will imply, if we ignore the unit, we will have 2x plus 3 is equal to 3x minus 5. So this will imply, if we solve for x, we will have x is equal to 8. So the correct choice is D. D is the correct choice. Okay, let's do question number 11. Question number 11. The bisectors of two adjacent angles of a parallelogram. The bisectors of two adjacent angles of a parallelogram intersect at, it will be 90 degree. So this is a very standard result. You should always remember that the bisectors of any two adjacent angles in a parallelogram always intersect at 90 degree. So question number 11, answer is choice D, that is 90 degree. This problem I have already solved in the previous video, or maybe in the it should be either in solving exercise 16a or 16b. Question number 12. How many diagonals are there in a hexagon? For hexagon, we know n is, the number of sides is 6. So this will imply, we know that for a polygon of n sides, number of diagonals is equal to n into n minus 3 whole divided by 2. This is the formula for finding the number of diagonals in a polygon of n sides, and hexagon is a polygon of 6 sides. So if we put 6 as the value of n, we get 6 into 6 minus 3 by 2. This is equal to 9. So we have 9 diagonals in a hexagon. So the correct choice is C. Question number 13. Each interior angle of a polygon is 135 degree. Each interior angle of a polygon is 135 degree. This means that it is a regular polygon, since all the interior angles are equal. So it must be a regular polygon. So how many sides does it have? Okay, so each interior angle of polygon of each interior angle of n-sided regular polygon, we know the formula is 180 degree multiplied by n minus 2 divided by n. So this is a formula for the measure of each interior angle of a regular polygon of side n. Now since it is given that each interior angle of a polygon is 135 degree, it means that the polygon must be regular, as all its interior angles are equal. Only in a regular polygon all the interior angles are equal and also all the exterior angles are equal. Okay, so we have this. So this will imply that 180 degree multiplied by n minus 2 by n, each interior angle is already given to be 135 degree. So if we ignore the degree, we will have 180 multiplied by n minus 2 divided by n is equal to 135. We have to find n. We have to find n, where n is the number of the sides of the polygon, and which will obviously be a regular polygon. So doing cross multiplication, so this is a linear equation in n. We have to solve for n. We have 180 n multiplied by n minus 2 is equal to 135 n. Simplifying the left hand side, we have 180 n minus 360 is equal to 135 n. Bringing all the n terms to the left hand side and all the constant to the right hand side, we have 180 n minus 135 n is equal to 360. So this implies 180 n minus 135 n is 45 n is equal to 360. So this implies n is equal to 360 divided by 45, and this is how much? This is 8. So the polygon, which is a regular polygon, has 8 sides. So the correct choice is B. B is the correct choice. So that is section B. Now let's do section C. Question number 14. These are fill in the blanks. Number 1. Sum of all exterior angles. So it is saying that for a convex polygon of n sides, sum of all exterior angles is always 360 degree. For a convex polygon, we always have the sum of the exterior angles is always equal to 360 degree irrespective of the number of sides. Okay. 2. Sum of all interior angles. Sum of all interior angles will be 180 degree multiplied by n minus 2, where n is the number of sides of the polygon. Okay. Number 3 is number of diagonals. So number of diagonals is n into n minus 3 divided by 2. Okay. Question number 15. These are also fill in the blanks question. 1. Part 1. For a regular polygon of n sides, okay, so for a regular polygon of n sides, we have sum of all exterior angles. It will be 360 degree. So in general, for a polygon, for a convex polygon, no matter what is the number of sides, the sum of the exterior angles is always equal to 360 degree. Okay. Part 2, sum of all interior angles. So, sum of all interior angles in a regular polygon of n sides will also be 180 degree multiplied by n minus 2, because this formula 180 degree multiplied by n minus 2, this is in general for any convex polygon of n sides, and a regular polygon of n sides is obviously also a convex polygon of n sides. Okay. Question number 16, part 1. So, this is also based on for a regular polygon. Okay. So, each interior angle of a regular octagon, is how much degree? So, octagon means n equals to 8. So, this implies interior angle, let us say I am abbreviating as each interior angle as IA. So, IA will be the formula is for a regular polygon of n sides, each interior angle is 180 degree multiplied by n minus 2 divided by n. So, this will be, it is talking about a regular octagon where n is 8. So, we must have 180 degree 8 minus 2 divided by 8. This is 180 degree multiplied by 6 divided by 8. This is equal to 2324 and then 45 degree. So, this is 135 degree. So, each interior angle of a regular octagon is 135 degree. Part 2, the sum of all interior angles of a regular hexagon is, the sum of all interior angles of a regular hexagon. For a regular hexagon, n is equal to 6. So, sum of all interior angles, I am abbreviating that as SOI, means sum of all interior angles will be equal to 180 degree. We know the formula is n minus 2. 180 degree multiplied by n minus 2 is the sum of all interior angles for a convex polygon of n sides. So, the problem is asking about the sum of all interior angles of a regular hexagon. Now, whether it is regular or irregular, it does not matter. We need the number of sides. So, hexagon means number of sides is 6. So, this will be 180 degree 6 minus 2. This is 180 degree multiplied by 4. This is 720 degree. Okay. Part 3. Each exterior angle of a regular polygon is 60 degree. Each exterior angle of a regular polygon is 60 degree. This polygon is a, okay, so we have to find the number of sides, and based on the number of sides of the regular polygon, we have to name the polygon. Okay, so we know that for a convex polygon of, for a regular polygon of n sides, each exterior angle of n-sided regular polygon is equal to 360 by n, this much degree. Okay, it is given that each exterior angle of a regular polygon is 60 degree. So, this implies that it is given 360 by n is equal to 60. So, this implies n is equal to 360 by 60, which is equal to 10. So, n is 10. So, this means polygon is a regular regular decagon. Regular decagon. So a polygon having 10 sides is known as decagon. Deca means 10. Okay. Part 4. Each interior angle of a regular polygon is 108 degree. This polygon is a, okay, so we have to basically find the number of sides. So I am doing the solution in short. So we have each interior angle of a regular polygon is 180 degree multiplied by n minus 2 divided by n, where n is the number of sides of the regular polygon. This is given to be 108 degree. So this implies if we ignore the degree, we have 180 multiplied by n minus 2 divided by n is equal to 108. We have to solve for n. Doing cross multiplication, we have 180 multiplied by n minus 2 is equal to 108 n. This implies, simplifying the LHS, we have 180 n minus 360 is equal to 108 n. Bringing all the n terms to the left hand side, we get 180 n minus 108 n is equal to 360. Simplifying further, the LHS becomes 72 n is equal to 360. This implies n is equal to 360 divided by 72, which is 5. So n is equal to 5. So this implies polygon is a regular pentagon, because a polygon with 5 as number of sides is known as pentagon. So this is a regular pentagon. Okay. The last one, 5, is a pentagon has how many diagonals? So a pentagon means n equals to 5. So this implies number of diagonals. I am abbreviating number of diagonals as NOD. Number of diagonals will be, the formula is n into n minus 3 divided by 2. This will be 5 into 5 minus 3 divided by 2. This is equal to 5. So it has 5 diagonals. So this brings to an end in solving the problems of test paper 17, even though I skipped a lot of problems because I have already solved those problems from the previous exercise 16A and 16B from the textbook of author RS Aggarwal. I hope this video will help you in understanding how to apply the concepts of parallelograms to solve these kind of problems. So if this video was beneficial, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I will prepare 2 assignment problems based on the chapter of combining the concepts of the chapters polygons, quadrilaterals and parallelograms. And then also I will start preparing relatively harder problems on these chapters for the other playlist, that is Maths 8 Hot. So these videos are coming soon, so please stay tuned. I will end the video here. Thanks for watching, and until the next video, take care and bye.